Hello everyone, thanks for coming here. My name is Ran Ren. I'm the presenter of today's topic. The topic we are going to talk about today is an extensible construction ontology to guide job site sensing and support information management. In my today's presentation, I will go through the introduction and background information to give you an overall regarding my research topic. Then I will introduce the ontological model development procedure to help you better understand my research topic. After that, I will introduce the model evaluation and then give you a demo regarding my ontological model that is integrated in a user-friendly interface. So at the end of my presentation, I will give you the conclusion and the future work. So let's get started. Construction site contains various types of data represented in different ways. Therefore, successful collection and use of such data plays an essential role in supporting construction information management, such as construction monitoring application. The figure on the right shows the three main components that we need to consider to support the construction monitoring application. They are the construction job site information, construction documents, such as specifications, and sensing techniques. The figure on the right shows the relationship among the three main components. For example, we need to extract the execution steps from the construction document, such as specification, then use it as a gold standard to compare it with the real execution steps on the construction job site to fulfill construction monitoring applications. In addition, the information that is extracted from the construction document could help us select the specific sensing techniques to help collect data on the construction job site. The research presented in this paper examines the new construction tasks, resources, and techniques integrated ontology that is extensible. This ontology classifies construction site information based on their nature and the data collection requirements, then provides encoded sensing techniques recommendations regarding data collection methods for specific construction site information. In this research, we developed this ontology to demonstrate the connections between construction site information and their corresponding sensing techniques. For targeted job site data collection with appropriate sensing techniques. In addition, a computational reasoning framework powered by this ontology is also proposed to provide sensing techniques, recommendations, and further support construction information management. This purpose demonstrates the represented information in the ontology, including construction site information and sensing techniques, classified hierarchically. This figure demonstrates the ontology development procedure. The purpose of this ontology is to identify sensing techniques that fulfill given construction applications and site conditions. We conducted a literature review regarding construction site information and sensing techniques for data collection, which helped define the concepts and their relationships. The proposed ontology is encoded in the Prodigy using OWL. The ontology development procedure involves iterative evaluations and improvements of this ontology from quantitative and qualitative perspectives. In addition, associating construction texts and resources with their corresponding sensing techniques for data collection is a core theme for this ontology development. Therefore, this ontology could guide engineers, managers, and other site personnel in collecting job site data and further support construction information management. The proposed ontology covers construction site information that affects the sensing technique selection, including resources class and tasks class. In terms of the resources class, it includes labor, materials, and equipment. Similarly, in terms of the task class, it includes labor-based activity, Equipment-based activity, labor and equipment-based activity, labor and material-based activity, labor and equipment and material-based activity, and equipment and material-based activity. The corresponding sensing techniques for each construction resources and tasks were incorporated in the extensible ontology and assigned to the specific resources and/or tasks. The information mentioned above was encoded in the proposed ontology using web ontology language in Prodigy software. Then the encoded ontology was implemented with a user-friendly interface. Python programming language was used for implementing the developed ontology interface. This figure illustrates the ontology-based app with zoomed-in looks. This figure demonstrates the steps of using the developed interface. From starting reading the interface title, then read interface instruction. After that, you select the target information that needs to be collected. Then select specific button to get sensing technique recommendations. So the sensing technique recommendation with their reference literature will be provided as reference. After introducing the ontological model, let's talk about the model evaluation. Since the model ontology evaluation is critical for ensuring reliable information management in multiple domains. In this research, the proposed ontology was evaluated in providing recommendations regarding appropriate sensing technique selection for supporting the collection of specific construction site information in a given scenario. In my research, the computational efficiency and consistency were used for quantitative analysis, and adaptability was used for qualitative analysis. This table shows an overview of ontology evaluation methods. Now let me give you a demo regarding this integrated user-friendly interface. When running the algorithm, it will show you an interface. On top of that, it shows the main contents of this ontology. It shows, please provide the necessary information below. The recommended sensing techniques with their reference literature will be provided in the corresponding colored bar. Then it shows you the different categories as included in this ontology. If you select the different activities or items in different classes, then press the corresponding button in this interface. The recommended sensing techniques with their reference literature will be provided in the corresponding colored bar. This research presented an extensible construction tasks, resources, and techniques integrated ontology by encoding construction site information, its corresponding sensing technique for data collection, and the relationships between them. It covers the major types of information on the construction site and may need support by sensing techniques in data collection. It demonstrates that the developed ontology is extensible and flexible, and could be implemented in the contraction domain to help provide the sensing technique selection recommendations regarding data collection methods for specific contraction resources and tasks. In addition, it could support their tasks in contraction information management. For future work, we plan to extend the categories of contraction information and sensing techniques in the proposed ontology to cover a broader scope for users in different types of contraction products. Thank you for attending my today's presentation. I will open the floor for any questions and comments. Thanks.